Okay, so today we're going to look at Test 6, Section 3 of the College Board exams. Question 1. Salim wants to purchase tickets from a vendor to watch a tennis match. The vendor charges a one-time service fee for processing the purchase of the tickets. The equation T equals 15n plus 12 represents the total amount in dollars Salim will pay for n tickets. What does the 12 represent in the equation? So as you can see, this is a linear equation, so it follows the format of y equals mx plus b. So the 12 corresponds with the letter b, which is known as the y-intercept. So on a graph, that would show up as where you're crossing the y-axis. So in particular, that's going to be like a starting point. So anytime you're dealing with the y-intercept, it's a starting point. And so it's going to be having the same units as t, so it's going to have dollars as its units. And it's going to be the starting point in dollars when n is equal to 0, right? Because your x value is 0 at that height, right? So it's not the price of one ticket, it's the amount of the service fee, yeah. So before you even buy any tickets, you have to pay some flat rate, and that's what that 12 represents. A gardener buys two kinds of fertilizer. Fertilizer A contains 60% filler materials by weight, and fertilizer B 40% filler materials. Together, the fertilizers bought by the gardener contain a total of 240 pounds of filler materials. So for A, it's 60% of A is filler materials. For B, 40% of B is filler materials. So if we add those together, we should get the 240 pounds of filler materials. So they're saying to let sort of X represent the one for A, so we can put that here, and then B, instead of B we should use Y, and then we get something that looks like choice B. What is the sum of the complex numbers 2 plus 3i and 4 plus 8i? So if we add those together, we add the real parts to get 6, and we add the imaginary parts to get 11i. That's answer choice C. Notice we didn't even need to use this fact. So on this one, we're equating coefficients, so we're going to have to FOIL out the right side. So we start with the first, which gives us p times p is p squared, x times x is x squared. Then we do the outer, which gives us minus tpx. Then we do the inner, which is plus tpx. And then we do the last, which would give us minus t squared. Inner and outer will cancel. So on the left side we have 4x squared minus 9, and on the right side we have p squared x squared minus t squared. And what we now can realize is that these x squared terms have to have the coefficients matching. So that means that 4 equals p squared, which means p is plus or minus 2. And similarly, these also have to match, these constant terms. So that means negative 9 equals negative t squared, and therefore t is equal plus or minus 3. But since it's asking for p, we'll choose choice A. Which of the following is the graph of the equation y equals 2x minus 5 in the xy plane? So this is a linear equation which has a slope and a y-intercept. So if we're to graph it, we always like to start with the y-intercept of minus 5, which this one satisfies, and this one also satisfies. But this has a positive y-intercept, and so does this. Okay, so we're down to B and D. And at this point we look at the slope. So we're looking for a positive slope, so as we read it from left to right, the function should increase. And in particular, if we take a single point, we should go up 2 and over 1. Right. So for this one, we have y is equal to 18, so we could just take the 18 and plug it in for y. Okay, so x equals 2/3 times 18. 18 over 3 is equal to 6. 6 times 2 is 12. So once we have x, we can plug it in here. 2 times 12 is 24, so that makes 21. Okay, so we have here this equation, and we would like to find L in terms of the others. So that means isolate L. So this whole thing could have just been boiled down to two words, isolate L. Okay? So to isolate L, we have to move the things that are attached to it to the other side. So we could divide by 7h. That would cancel those out. So we'd get L equals n over 7h. Okay, so for which value of x is w of x plus t of x equal x? So when we add the value from this column and the value from this column, we should be getting the value in the first column. So let's see if it works. -1 with -3 makes -4. So that does not work. Let's see. 3 combined with -1 makes a 2. So that does work. So when x equals 2, these do combine to equal 2. Right. Okay, radical x plus radical 9 is just 3, equals radical 64 is just 8. So we could subtract 3. Rad x equals 5, square both sides, x equals 25. Jamie is preparing for a bike race. His goal is to bike an average of at least 280 miles for 4 weeks. He biked 240 miles the first week. Right, so when we do an average, that's going to equal sum over number. So we can already start beginning to set up our average, which is to find the sum. So that's the first week, second week, third week. So we could do 240, 310, 320, and since we don't know the fourth week, we can use x for that, then divide by 4. So that expression will give us the average. And since we want the average to be at least 280, we want this to be either greater than or equal to 280. So from this point, we can simply move the 4 in that direction, and that will give us something that looks like answer choice D. Okay, which of the following is true about the parabola with this? Okay, so we're comparing this with this. What we notice right away is that the plus c is the same. So it has the same y-intercept. But this might shift left or right, the graph. So let's see. Yeah, so it appears like this right here is telling us that there's a shift involved. Okay. So this is a shift to the right by b, right? So instead of being where it's at now, the vertex is going to be moving to the right by b. So the new vertex we expect to see at an x value equal to b, and the y value will still equal c, right? That's the vertical translation. This is the horizontal translation. The only other difference is that instead of a in front, we now have -a. And what that means is that we're going to have to flip everything vertically. So we're going to have to flip in the x-axis. So let's see. So the vertex, so the graph is definitely going to open downwards, right? Because of the negative in front. Downwards, okay. And so the other thing is, right, we need to just identify what the vertex is. And so the vertex should be b comma c, right? Yeah, because whenever we're in parentheses, it's always opposite direction than we would normally do. Which of the following is equivalent to this, right? So one thing you cannot do, of course, is to do any sort of cancellations here, because these are in parentheses, right? Terms versus factors. So we can factor out, well, actually, now that I glance at the answer choices, I see what we're going to have to do is sort of a long division process. So let's set that up now. 4x squared plus 6x. So this can go into this, let's see, x times, and then we would multiply through by x, so we get 4x squared plus 2x, and then we'd subtract these lines. This would cancel. This would give 4x. So this can go into 4x once, right? And so we've already kind of seen now that this is going to end up being the answer, but just in case we didn't know that, we could sort of put a plus 0 here, and then we could say, okay, 1 times 4x plus 2, so that goes here. And then when we subtract, we get negative 2, and you could see that's actually coming in as the remainder, right? Because we have nothing more to do here. So we say that the remainder then is negative 2 divided by the divisor, which is 4x plus 2. In the equation above, t is a constant. If the equation has no real solutions, which of the following can be the value of t? So what we can do is we could subtract the t to the left, because whenever we have a quadratic, we always want everything on one side with 0 on the other side. So let's see. At this point, what we might want to do is simply to plug in some of these choices and see what might work. So this is the no calculator section, so we cannot use a calculator here. Let's see. Well, okay, here's an idea. So instead of moving the t over, right, we can use the idea of completing the square. So let's use that as a nice exercise here. And in addition to completing the square, what another option would be, we can use the nature of the roots. Nature of roots. So we can explore that idea as well, because it says has no real solutions. Yeah, maybe we ought to do that instead. So, because if it did have solutions, completing the square would work out nice. But if it doesn't have solutions, then that comes down to the nature of the roots. So the nature of roots is gotten by looking at b squared minus 4ac, which is part of the this thingy, right? The quadratic formula. Should be negative b. Yeah, so it's the part of the quadratic formula that's underneath the square root symbol, right? So that's the part that governs what kind of roots we're going to have. So in this case, we want to have imaginary roots, right? Because we don't want the roots to be real. So to have imaginary roots, we must demand that that's less than 0. So yes, we are going to swing this t over back to this side. Okay, and now we need to say what a, b, and c are. So a is going to be 2, b is negative 4, c is negative t. So now we're going to plug those in. So negative 4 squared is 16 minus 4 times 2 times negative t. So we end up with 16 plus 8t. Okay, and so we subtract 8t, subtract 8t. 16 is less than negative 8t. Divide by negative 8, and we find that negative 2 is less. Oh, and when we divide by a negative, of course, we have to switch the inequality sign. And then at this point, we can sort of pancake this equation so that the point still goes towards the t. So this reads t is less than negative 2. So the only one less than negative 2 is negative 3. So that's the one that satisfies the requirement that the roots have to be imaginary, right? That's the imaginary requirement. Okay. So the ones with a lot of words like this, I like to just kind of highlight the important parts. Some of it will be kind of obvious, right? So that first sentence, for example, I don't even probably read because it's not going to tell me anything enlightening. It's not going to provide any numbers. So the supplier will deliver no more than 300 pounds. So right away, I know that no more than means it could be less than or equal to 300 pounds. So anytime I see anything greater than, I'm going to cancel it out, which I don't in this case. Each container of detergent weighs 7.3 pounds, so 7.35 pounds times the number of detergent. So detergent is going to be D. Okay, and then I'm going to probably have to add that with 6.2 times the fabric softener, which is S. So choice A is looking good from that first equation. This equation matches that, and these two are no good. So now it just comes down to getting the second equation. So where's the other restriction? Let's see. So here, the service wants to buy at least twice as many containers of detergent as fabric softener. So when I compare the detergent with the fabric softener, I want one to be twice the other, at least. So the question is, do I put the two here or do I put it here, right? So the way to do it is to find out which one would be more. So let's see, do we have more detergent or more fabric softener? So I think we have more detergent, right? So that's why I would put the S over here, because since this is already the larger number, it doesn't need to be multiplied by 2 to make an equation. The smaller one would need to be multiplied by 2, right? And at least that much means it could also be greater or equal to that, right? So that's the second equation we expect, so choice A seems to be the one. All right, which is equivalent to this. So for here, what we have to do is we have to actually FOIL, right? A plus B over 2. So first is A squared, outer is AB over 2, inner is AB over 2, and last is B squared over 4. Okay, now these inners and outer will add up because they are like terms. So there's a few ways you could think about this, but my favorite way is you could sort of see that there's a 1 in front of both, so now there will be a 2 with the same tail of AB over 2. Okay, and then of course the 2's here can cancel to give you a full AB. And so that matches with choice D. So that's it for the multiple choice. Now we're on to the grid-ins. Right, so here we have an equation. What is one possible value of B? Since they want one possible value, that means there's more than one way to do it. So the way I look at this is maybe this is supposed to be 4 squared, because that's another way to get 16, right? So that means that A to the B over 4 has to somehow equal 4 squared. And that can be accomplished if A is equal to 4 and if B over 4, the exponent, is equal to 2. Which means that if I multiply by 4 both sides, or simply move the 4 across the equal sign diagonally, I find that B would have to equal 8. And of course you could have also used 2 to the 4th. Right, so with this one, first of all, I'd rewrite it a little bit like this. And if I'm solving for t here, I would use my movement system to move the 3 diagonally across and to move the 2 downwards, right? At this point you can multiply tops and multiply bottoms and you'll find the result. Okay, so here we have a case of similar triangles where overlap is occurring, and we want to know the value of CE. So the first thing we can do is we could find the two similar triangles. We have this purple triangle here, and then we have the big one, the red one. And if you prefer, you can draw them out separately. Okay, so we could say that this is the red one, and we can say that the purple one is somewhere here. So this has dimension 6 by 8, and this bottom dimension is unknown, but we can actually solve for it. So we can solve for it by noticing that the 6 is multiplied by 3 to get 18. And so 8 multiplied by 3 would be 24. And a more sort of consistent way of doing that, which doesn't require any mental math, would be to set up a proportion between the respective sides. So now that we know that value, we can find CE, which is this, by doing a Pythagorean theorem. So we would do 18 squared plus 24 squared. Now, we may or may not want to do that kind of math without a calculator. So we might want to look for another pattern that we may be able to exploit. So we know about Pythagorean triples, for example 3, 4, 5, right? But what you may not know is that there's a rule that says any multiple of that would also be a Pythagorean triple. So let's see if what we have here, and let me just actually rearrange the 3 and the 4, is a multiple of that. So if we look at this one, then we notice that if we were to multiply by 2, let me see, yeah, 3, 4, right? If I multiplied by, yeah, okay. So now I can actually just notice that this would be multiplied by 6 and this would be multiplied by 6. So this is sort of 6 times a Pythagorean triple. This is 6 times 3, this is 6 times 4, so this one would be 6 times 5. 6 times 5, of course, is 30, so that would be our answer for CE. That saves you a little bit of multiplication. Right, so how many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? Okay, so whenever it says sort of how many liters, we can just call that X, right? So right now, what we have is a 25% saline solution. Okay, and we're going to take X liters of that. Let's see. And we also have right now a 3 liters of a 10% saline solution. And together we want that to make a 15% saline solution. And how many liters would it be? Well, it would be X plus 3 liters, right? So if you notice the structure of how I'm setting this up, it's kind of like a weighted average. The weights are these numbers out in front, okay, which tells you sort of what percentage we're dealing with. Actually, those technically are not the weights. The weights are actually these numbers probably, right? Because these numbers, yeah, are telling us how many liters that we're doing. And to be completely consistent, we can divide by X plus 3 on both sides, but I think this is going to be fine. So anyways, we just have to solve for X, right? So 0.25X plus 3, or sorry, 0.3 is equal to 0.15X plus 0.45. And so if we subtract 0.15X, we get 0.10X. And if we subtract 0.3, we'll get 0.15. So if we then divide by 0.1, that's the same thing as multiplying by 10. So we'll end up with 1.5 for X. Points A and B lie in a circle with radius 1. So the radius is 1. And arc AB has length pi over 3. So if we draw this circle, and we have points A and B, the arc length here is going to be pi over 3. What fraction of the circumference of the circle is the length of arc AB? Okay, so the circumference of a circle with a radius of 1 we can find by using c equals 2 pi r. So 2 pi times 1 is just going to be 2 pi. So that's our circumference. So the question is asking, what fraction of 2 pi is pi over 3? Right? So let's list that out again. What fraction of 2 pi is pi over 3? Okay, so now using our sort of math English dictionary, we can figure this out, or we can just simply divide them, right? So the third way to do it is use sort of is over of. So there's one way. What fraction would be x in the math English dictionary of 2 pi, so times 2 pi, is means equals pi over 3. So there's sort of one way to do it. The is over of is also another way. So is pi over 3, so the pi over 3 goes where the is appears. Of 2 pi, so the 2 pi would go here. And then what fraction? Yeah, so in this case we don't even need the percent over 100, we could just use x, right? So yeah, so we could solve this out by keep change flip, right? 1 over 2 pi, the pi's will cancel, we get 1/6. So that's telling that it's 1/6 of the entire circle, right? And that should be kind of familiar because we know that 2 pi corresponds with 360 degrees. And how many degrees would pi over 3 correspond with? Well, it would be 180 over 3, right? So that would be 60 degrees. So yes, it does match our intuition that it's 1/6 of the circle.